Delicious chemistry! Yum, 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 yum! Hey guys, welcome back to chemistry. We're still continuing on writing formulas. Today we're going to be focusing on acid formula writing. Okay. Now what you have in front of you are the rules for um, writing acids. Remember, we don't care about the H because all acids have H. That's how we know it's an acid because it starts with an H. Okay. Where ionic starts with a metal, covalent start with a nonmetal, acids start with an H, and we don't care about them, okay? So what we care about is what happens after the H, okay? What happens after the H? Well, we have two possible outcomes here. Either you have a single nonmetal or you have a polyatomic, okay? Now, if it's a single nonmetal, which means you're going to find it over here somewhere, all you got to do is put hydro in the front, ic on the back, and then say acid, okay? Now, if it's a polyatomic, you're going to look up the polyatomic on the polyatomic chart that we have, and you're going to look at the ending of the polyatomic. If the polyatomic ends in 8, you're going to turn it to ic and say acid. And if it ends in ite, you're going to turn it to us and then say acid. So that's what we covered last time. Well, when you write the formulas for a compound, we're just reversing this process, right? Because if you look, right here, I'll give you an example. Acids act just like ionic compounds. I mean, exactly the same way. For example, if I have HCl, hydrochloric acid, right? We have the H with the +1 oxidation number, or chlorine with the -1 oxidation number. And when these two guys want to hook up and bond, they swap and drop their oxidation numbers, and that's how we get the HCl, right? Just like ionic compounds, because acids are ionic compounds, right? They're just special because they start with H's, and you'll learn more about acids later, okay? Now, when it's time to write the formula for an acid, all we're going to do is reverse this entire process, okay? So let's talk about acid formula writing real quick. There are 3 rules when we're dealing with acid formula writing, and it's the exact same rules when you're dealing with ionic formula writing. You're going to pull out the players, assign oxidation numbers, and then swap and drop. You're going to do the exact same thing. The thing is, though, when you pull out the players, the first player is always the same, right? The first player is always hydrogen. So then all we care about is what happens after hydrogen. You need to remember, if the compound they give you starts with hydro, that means that not polyatomic, you're going to find this one on the front of the periodic table. The front of periodic table, okay? You're going to find it on the front of the periodic table, which means if you see the word hydro in the name, the nonmetal is going to be one of these guys here. Okay, because that's what we're looking at here, the nonmetal. Now, if you don't see hydro, right? If you don't see hydro, that means this guy is a polyatomic. Okay? That means he's a polyatomic. So what you're going to do is you're going to reverse that process. What polyatomic are they talking about? Well, you have 2 options. Remember this? 8 turns into ic, and ite turns into us, right? So you're just going to reverse the process to find your polyatomic. So when we're writing the formulas for acids, we pull out the players, but we got to figure out what we're doing with this nonmetal. So I got some examples here so I can run with you so you can get what we're talking about here, okay? So hydrochloric acid, we just did this example. The word hydro tells me that the nonmetal is a single element. So who is chloric? Well, it's chlorine, right? Cl. Acid tells me automatically it's starting with an H, right? So if you see an acid, automatically put that H down first because you know it starts with an H. So hydro tells me it's a single element. Chloric means it's chlorine. So all I got to do is assign oxidation number. Well, hydrogen is always 1. And if you come over here to chlorine, he happens to be -1. So when I write this guy, he's going to be +1, -1. And then so all I got to do is swap and drop, right? So we end up with HCl. So this was a real basic one. Hydro means a single element after the H. So now, let's look at this next example. Sulfuric acid, okay? Do you see a hydro? No, you don't. So no hydro means what? No hydro means this guy is a polyatomic. So I'm going to first start off by writing the H. Since I know it's an acid, he's a +1. Done. All acid starts with H +1. So I got to figure out the sulfuric part, the polyatomic. Well, sulfuric, let's see, where did ic come from? Ic came from 8. So let's put it back. So instead of being sulfuric, this is sulfate. So I want to look up sulfate on my polyatomic sheet right here, okay? Here's sulfate right here. SO4 with a -2 oxidation number, right? Sulfate, SO4, -2 oxidation number. So I'm going to write that. SO4 with a -2 oxidation number. All I did was reverse what I saw here. Ic came from 8, so this is sulfate. And I just look it up on the polyatomic chart. Now you're going to do the same thing. Oxidation number switch. And we end up with H is going to get that 2. SO4 gets a 1, but we don't write 1s. H2SO4. Easy stuff, right? So let's do another example. Hydrofluoric acid. Well, since it's an acid, I know it's going to start with an H, and he has a +1 oxidation number every time. So I got to figure out who the nonmetal is. Well, let's look. It's fluoric, but there's a hydro on the front. So what does hydro tell me? If there is a hydro, that means you're going to find it on the front of the periodic table. So what element here in the nonmetals could be fluoric? Well, there's only one guy that's fluorine, right? F. So we're going to put F. And, oh, by the way, what's his oxidation number here? -1. So I'm going to go ahead and take that with us. F with a -1. So what do you do now? You swap and drop, right? You're going to take the two numbers and swap and drop. But do we write 1s? No, we don't. So it just becomes HF. Okay. Really simple process. Let's do one last example together. Okay. Phosphorus acid. Okay. Well, since it says acid, I know this is going to be H+, right? So I got to figure out what the nonmetal is. Well, I'm going to look at it. Uh-oh, I don't see a hydro. So if there's no hydro, what does no hydro tell me? No hydro means it's a polyatomic. So this guy is a polyatomic, phosphorus, okay? So I'm going to look at, okay, what polyatomic is this guy? What does it end with? Well, this one is ending with us. So phosphorus, where did us come from? Us came from ite. So I'm going to put it back. This guy is phosphite, right? Us came from ite. So that means this guy's name is phosphite. So I'm going to pull out my polyatomic chart again, and I'm going to look for phosphite. So I'm looking, phosphate? No, not phosphate. Here it goes. Phosphite. Here it goes. Got to make sure you get the right one. They all look similar. Phosphite. That's PO3 with a -3 oxidation number. Phosphite, PO3 with a -3 oxidation number. So let's put that down. PO3 with a -3 oxidation number. That wasn't hard at all, right? So now we're going to do the same thing. We're going to swap and drop the oxidation numbers, and we end up with H is going to get 3, and PO3 is going to get 1, but we don't write 1s, so that's that, okay? So guys, this stuff isn't hard. Hydrogen's always +1. You just got to figure out who that nonmetal is. And figuring out the nonmetal is actually really easy. If there's a hydro, it's a single nonmetal, and you're going to find it on the front of the periodic table. If there's no hydro in the name, that means it's a polyatomic, and you got to reverse what they did. Ik turns into ate, and us turns into ite. Okay? So guys, that is acid naming. Have a great day.